right, let's take a look at this question. A ball is such that when it is dropped from a height of 1 meter, it bounces vertically from the ground to a height of 0.96 meters. Let me try drawing this. Okay, so there's a ball that is dropped from a height of 1 meters. It goes down, and this distance is 1 meters. Then it goes up, but not completely all the way back up, but to a height of 0.96 meters. So this goes up till 0.96. And of course, if it's going up, it also comes down to the same height or covering the same distance. This is again going to be 0.96 meters. Okay. It continues to bounce on the ground, and each time the height it reaches is reduced. Two different models, A and B, describe this. Okay, so every time this ball drops, it loses or bounces. Every time this ball bounces, it loses some height. That is what the question is trying to say. Now, there are two models mentioned here. The height is reduced by 0.04 meters each time the ball bounces. Okay, so if we're using this model, it is now going to be in the next trip, this ball is going to go upwards and it's going to cover a distance of, we're going to do 0.96 minus 0.04. It's going to be 0.92. It's going to cover an upward distance of 0.92 meters and a downward distance of 0.92 meters. And so on. This would be an AP. Let me mention that. So for part 1, they're asking us to use model A. Let me just talk about that. 1A is an AP. Okay. AP is going to be, A is going to be 0.96 or 1. Let's just first finish reading this question. I think I missed some part of the question. Okay. So we're not looking at model B for now. And then in part 1, it says find the total distance traveled vertically upwards and downwards by the ball from the first time it hits the ground until it hits the ground for the 21st time. All right. So it says to find the total distance traveled from the first time it hits the ground. That means after this point. That means we start from here. So we include all of this. But we do not include the first 1 meter fall because the question is clearly stating find the total distance traveled by the ball from the first time it hits the ground. So it's telling you not to consider this. Ye nahi lena. And you start with 0.96. So A is going to be 0.96. I'm only looking at the upward motion right now, not the downward motion. And D, the common difference is going to be negative 0.04 as the distance reduces by 0.04 every time. Okay. And let's read this again. By the ball from the first time it hits the ground until it hits the ground for the 21st time. Now, since we're not considering the first fall, so between the first fall and the 21st fall, you're going to have 20 terms. So you're going to do 21 minus 1, 20. Why is that? Why are we subtracting 1 from 21? Because we are not considering the first 1 meter fall. So n is going to be 20 and not 21. So now we have to find the total distance traveled both up and down by the ball. Okay, so will have to use the sum of first 20 terms formula. But that is just going to give us the upward distance traveled. we will also have to double it because there are two series in parallel going on. There's 0.96, 0.92, and so on for the upward motion. And similarly, there's 0.96, 0.92, and so on for the downward motion. So we're going to find the sum of the first 20 term for the upward motion and double it. So we have to do 2 times sum of first 20 terms. That's going to be n over 2 times 2a plus d, but our d is negative, so negative d times n minus 1, 20 minus 1, which is 19. So this gives, enter this in the calculator and also do not forget to double it. I did not double it. Whatever is the answer, we do times 2. So this would give us 23.2 meters. So this was for model A. Okay. Now let's do the same, but this time we'll use model B. Okay, so model B says, let's read the details. Okay, it says that the height is reduced by 4% each time. Let me clear this slightly. Okay, so now the height is reduced by 4% each time it hits the ground. That means it's a GP. We've discussed before in class that if it's 4% or any percentage mentioned, that means it's GP. So A is still 0.96 and N is still 20. Now we need R. And I've taught you the shortcut of finding R in such questions. It's a 4% reduction. 4% reduction means 96% of something. So that's going to be 0.96. Either you remember this fact and find R like that, or the other method is that you know what is the first term, it's 0.96. Now let's reduce this by 4%, get the second term, and then find R by using the formula any term divided by its previous term. So I'll show you that as well. So let's reduce 0.96 by 4%. So it's going to be this. Let's see what this gives us. 0.96 minus 4% of 0.96. That is giving me 0.9216. So the next term will be 0.9216. Let me fix that in the figure as well. 0.9216 meters. Okay, so now R would be a term divided by its previous term. Let's see if this gives us the same answer. So 0.9216 divided by 0.96, it gives us 0.96 again. So we got the same R. All right. Now let's find the sum of the first 20 terms of this GP and also double it. So it's going to be 2 times. The formula is A, 0.96 bracket 1 minus R is 0.96. So 1 minus bracket 0.96 bracket close. And the power of R is n minus 1. So 20 minus 1, that's going to be 19. And let's close the bracket. 19 is supposed to be on 0.96. Let me fix that. So power 19, bracket close, big bracket close, upon 1 minus R. So 1 minus 0.96. Enter this in the calculator very carefully and oh, I'm sorry, the formula is power n, not n minus 1. So it's supposed to be 20. Let me write down the formula for Sn over here. It's going to be given in the formula sheet. It's A 1 minus r n upon 1 minus r. So this would be 20, not 19. Okay. So enter this in the calculator and you would get 26.8, which is the answer for 1 part B. Okay. Part 2 is show that under model B, even if there's no limit to the number of times the ball bounces, the vertical distance traveled after the first time it hits the ground cannot exceed 48. Okay. So they're saying that no matter how many times this ball keeps bouncing, the maximum distance covered by this upward and both downward motion cannot exceed 48. Okay. Why are they counting the entire upward and downward motion? Is because the value of r is less than 1. Look at the value of r. R is 0.96. So it lies between 1 and minus 1. That means that it is a diverging series. The biggest value, sorry, converging series. It gets smaller and smaller because the first value was 0.96, then 0.9216, and then it keeps decreasing, decreasing, decreasing until it becomes 0. So they're asking you to find sum to infinity, but multiply that with 2 because you also have to consider the downward motion and show that it's 48. That is all you have to do. So for part 2, we just have to do 2 times sum to infinity. So 2 times a is 0.96 upon 1 minus r is also 0.96. Enter this in the calculator and you should get 48. And we've shown that we get 48.